everyone, welcome to another video on O-level physics, and in today's video we are going to cover the definition of velocity and acceleration, and we're also going to figure out how constant velocity and how constant acceleration differs from each other. How does an object move when it's moving with constant velocity, and also when it's moving with constant acceleration? So how they are different from each other, that's what we will be discussing in today's video. So this is the topic that you will be covering in your O-levels, the second chapter of your book, the course book. So let us start with it. Let us try to understand what velocity is and what acceleration is, how they are different from each other, and how we solve problems using these two concepts. All right, so let us begin with it. Okay, so let us start. Now, before starting, let us discuss a bit about what is speed and what is velocity. So we already know what speed and velocity, how they're different. That speed is a scalar quantity and velocity is a vector quantity. What is scalar and vector, that we will discuss in another part of the chapter. So here I'm not going into details in scalar and vector. So we know from the definitions of scalar vector that scalar does not depend on direction, and vector depends on both direction and magnitude or size of the quantity, right? So when we find speed of an object, when we try to calculate the speed of an object, we use the formula distance divided by time, this one, right? And when we are finding the velocity of an object, we use displacement divided by time. Now, both of them might seem very similar to each other, which is actually the case. They are very similar to each other, except for the fact that distance itself is a scalar quantity. Distance, we call it a scalar quantity. Time is always a scalar quantity. And displacement is called a vector quantity. It depends on the direction, just like the velocity of an object. So let us do an example quickly and let's figure out how they act or how they work. Let's say we start from a point A from here and we go up to a point B. All right. The distance from A to B is given 10 meters and a person takes 5 seconds to move from A to B. All right. The person then moves from B. He starts again from B and goes all the way to another point C. Now C is in the opposite direction, which is 6 meters. Now when we are calculating vectors, we usually put up this plus sign or minus sign to show the direction. The plus or minus does not mean that you have moved a distance which is less than 0. You can't move minus 6 meters or less than 0, right? So this minus over here, the minus sign is actually showing that we are moving in the opposite direction. So what happened? We started from A, moved to the right 10 meters, and then you moved in the opposite direction another 6 meters, right? So how much is your speed and how much is your velocity? Now when we are calculating speed, the formula is this one, distance divided by time, where the direction is not at all a factor. So what is the total distance that I have moved in this particular scenario? So I went 10 meters on this side, 6 meters on this side. The total distance moved is 16 meters. And how much time did I take? So the first 10 meters was moved in 5 seconds and the next 6 meters was moved in 3 seconds. So in total, I moved the total distance of 16 meters in 8 seconds. So my speed remains 2 meters per second. Now, when we talk about velocity, the velocity is a factor which you have to understand that velocity depends on the direction also. So while calculating velocity, as we have discussed before, we use displacement by time. Now, for calculating velocity, we have to calculate the displacement, not the distance. So how do we calculate the displacement? We move to the right 10 meters. We moved to the left another 6 meters. So our total displacement is positive, but 4 meters. The positive sign here means that I have moved 4 meters to the right from my starting point. How do I know that I have moved to the right from my starting point? Of the plus sign. Because you see, initially when I was considering 10 meters here, I took the right hand side as positive and the left hand side as negative. So the plus sign here shows that I have moved 4 meters away from my starting point in the right hand direction. So the displacement here is 4 meters. And the time taken for this displacement to occur is also 8 seconds. You see, 5 seconds to this side, 3 seconds to this side. the displacement is 4 meter in 8 seconds. So what is my velocity here? 0.5 meters per second. So this is something which is very important, and you have to keep it in mind that when you're calculating displacement, you have to consider the direction, and the velocity depends on the displacement, not on the speed. So the object's speed and velocity will be different for the same journey because of the direction. Now in the next part, we'll be discussing about how constant speed or constant velocity is defined, or how does an object move when it's moving with constant speed or constant velocity. We will consider constant speed or velocity to be the same because there is no change in direction. In most of the cases in your O-level exam or in your O-level questions, you will find the object is not changing direction, it's moving in a straight line. So as a result, we can take the speed and velocity to be the same because there is no change in direction. So let us watch on that part first now. Okay. Alright, so here we start with constant velocity or constant acceleration, and let's see how do each of them work. So as I said, we will consider constant speed or constant velocity to be the same in this case because the object is moving in the same direction. So let us start with the diagram. Let's say an object starts from point A and then moves on a certain distance. Okay, so it starts with this point, which we are considering as A. It moves a certain distance, B, and then it moves to C, then it moves to D and E, and so onwards, right? So let's mark these points. Here it's let's say this is B, then this is C, this is D, and this is E. Now an observer here an observer standing and looking at an object starting from A. So from A it starts moving over here. You draw an object, let it be a car or bus or something, I don't know. I really can't draw a car here properly, so let's just assume this is a car which is moving at a constant speed. So the observer is observing the motion of the car. He notices the motion of the car after every 1 second. Now what is A, B, C, D, E? Why do I have to mark these points? Now A, B, C, D and E, these distances are equally marked. That is, if the distance from A to B is taken, if say it's 2 meter, then the distance from B to C is also seen to be 2 meter. Okay, and same goes for C to D and from D to E. That is, the distance from each point from A to B, B to C, C to D and D to E is equally marked. They are equidistant from each other. And now the observer is watching how much time does it take for the object to move from A to B, then from B to C, then from C to D, and then from D to E, and vice versa. So let's see. He starts from A, moves to B in a time, let's say 1 second, right? And then in the next 1 second, he sees that the object moves from B to C, that is another 2 meter, and then from D to E, C to D, and then from D to E. So after every 1 second, the observer observes that the object has moved a distance of 2 meter. Okay, so the same time and the same distance after every 1 second interval. So the observer tries to find out the average speed of the car. How much did the car move in total and how much time did it pass? So if you find it out from the diagram, you see 2 meter, then another 2 meter, then another 2 meter, and then another 2 meter. In total, it has moved a distance of 8 meter, right? How much time did it take? It took a total of 4 seconds. So we find the speed to be 2 meters per second. Now the observer thinks, okay, so the total distance is 8 meter. The total time taken is 4 seconds. So 2 meters per second is the average velocity because of the entire journey. Now the observer thinks, what was the velocity or the speed of the object after every 1 second? Now if you try to find the speed of the object, let's say from A to B. How do we find that? The distance traveled from A to B is how much? Sorry, 2 meter. How much time did he take? Did the car take? 1 second, A to B, right? So the speed is 2 meters per second. You see, the average speed and the speed at any one point is the same. If you try to find the speed from B to C, again you will find it to be 2 meters per second. So an object is said to be moving with a constant velocity or constant acceleration So as I was saying, an object is said to be moving with a constant speed or constant acceleration only if the object covers the same distance after every 1 second. That is, in this case, the object is covering 2 meters after every 1 second. When you observe at an object moving away from you or towards you, doesn't matter. If you see that the object is covering the same distance after every 1 second, okay, we can say that the object is traveling at a constant velocity or a constant speed. Okay, if the distance is increasing or decreasing, then the speed is not constant. So if you keep your speed same, if you keep your velocity same, you will be covering the same distance after every 1 second. Your speed is what determines how much distance you cover in every 1 second. So this object is moving 2 meters per second. So after every 1 second, it has moved a distance of 2 meters. So if the speed of the object is 2 meters per second, how much is the velocity of the object in this case? The velocity of the object will also be 2 meters per second. Why? Because here the distance and displacement will be the same. The object is not changing its direction. So if the distance traveled is 2 meters in the forward direction, the displacement is also 2 meters because it's not changing direction. So in this kind of scenarios, we can say that the object is either moving with constant speed or constant velocity. Both of them are correct. None of them is wrong. Both the concepts are clear. Okay. So this is what constant speed or constant velocity means. So I repeat the definition. An object is said to be moving with constant velocity or constant speed only if it covers the same distance or only if it travels the same distance after every 1 second. Okay. All right. So we come to the next part, which is acceleration. All right. So when we talk about acceleration of an object, I'm pretty sure if you have any idea about cars or bikes, you have heard the term the acceleration of an object is this much, or acceleration of the car is this much, or acceleration of the bike is this much. Often in many TV commercials, or even in the commercials of cars and bikes, we come across this term, or we come across this kind of phrases that it travels from 0 to 20 kilometers per hour in in say, let's say 3 seconds or 4 seconds, doesn't matter, like something of that sort. Excuse my handwriting here. So if it travels from 0 to 20 kilometers per hour in 3 seconds or 4 seconds, why is it important? What does it actually mean? This speed of the object, let me write it here again, it's traveling at 0 to 20 kilometers per hour in a certain time, in 2 seconds or 3 seconds. Okay, so this is what actually acceleration means, how fast the speed of an object can change. Okay, when we say something has a higher acceleration, we actually mean that the object's speed can change very quickly. When we talk about acceleration, we mean that the velocity of the object is increasing. When we talk about deceleration, we mean that the velocity of the object is decreasing. That is the difference between acceleration and deceleration. If something has a higher acceleration, that means its velocity can change from a starting value to a new value very quickly. Like for this bike, if I say if it's moving from 0 to 20 kilometers per hour in 3 seconds, and if there is another bike which can start from 0 to 20 kilometers per hour in, let's say, 5 seconds, the one which can change the velocity in 3 seconds has a higher acceleration. And this is important in many, when there is a racing event or something of that sort, this acceleration is very important. Of course, the top speed is important, but the acceleration is also important. That is, how quickly can you change your velocity? Okay, so let us draw a diagram and try to figure out about this one. How does acceleration affect the movement of an object? So here, let us again draw a line and try to show the difference of the object's motion. Okay, so there is a straight line, and the object starts from this point here, right? From here, yeah. So it starts from A and goes with a velocity, starts with a velocity of 0 meters per second, right? Starting velocity is 0. It then travels for 1 second and goes here, right? So let's name this point B. and after 1 second you see that the velocity of the object, let's say, has become 5 meters per second. Okay, all right, so how much time did it take to go from here to here? It took 1 second. Now let us say after another 1 second you see that the object has traveled another distance, and now it is at C, and you see that the object's velocity at C is somewhat around 10 meters per second. It's not the same as before. So another 1 second passed. So from 5 to B to C, there is another 1 second which has passed. In total, it has traveled for 2 seconds. So from an observer's point of view, what are you seeing? That from A to B, the first 1 second, it traveled a smaller distance. Why? Because the velocity was less. It started from 0, it reached up to 5. So approximately, just an approximate, we can say that the object has traveled somewhat around 5 meter here, right? Let's say that's just an approximate because that cannot be an exact value. Okay, and from B to C, the speed of the object has become 10 meters per second. That is, it was 5, now it has become 10 meters per second. That means in 1 second, it has traveled a distance of 10 meter approximately. So let's say from B to C, the distance traveled by the object is approximately 10 meter, right? So you can observe that from A to B, it moved a distance of 5 meter. And then from B to C, it has moved a further distance. It moved very far in the same time, in 1 second. How did the object cover more distance from B to C than from A to B? How is it possible? Now, if you picture yourself in this one, if you were walking at 5 meters per second, in 1 second, you would cover only 5 meter, right? You wouldn't be walking very quickly, so you're covering only 5 meter. And then in the next 1 second, you start moving faster. Once you start moving faster, in the same 1 second, you can cover a larger distance, right? So when something accelerates, its velocity increases, right? That's we have already studied from the definition. Now, if the velocity increases, what change will we observe in its distance? Of course, it's going to cover more distance in the same time period. That is what acceleration means. Of course, the distance that I have given here, that 5 meter and 10 meter, is not a correct representation of the distance, but what I wanted to show you is that it is covering more distance in the same time. In every 1 second, it's covering more distance, and this is how the object is seen to be accelerating. So what is the acceleration of the object here? The acceleration of an object is found using the equation. Let me just write it down for you. Using the equation, change in velocity, let me write it down. Change in velocity of the object divided by the time taken for the velocity to change. So for this particular maths that we have drawn here, the diagram, if we write the change in velocity, how much is the change in velocity for the object? It started from 0 and it ended up at 10, right? So the change in velocity is 10 minus 0. How much time did it take? So it started from A, so let's say it's started from 0 seconds. Then it passed 1 second when it was at B, 1 second. When it came to C, another 1 second passed, so which is 2 seconds, right? So the total time taken from A to C is how much? 2 minus 0. It started at 0 second, ended at 2 seconds. So the change in velocity divided by time taken gives us 5. Unit of acceleration is meters per second square. Okay, so the acceleration of the object is found to be 5 meters per second square. That means after every 1 second time, you will see that the velocity is increasing by 5. We will talk more about this in the next video, where we'll also discuss about the velocity time graph and the distance time graph. But from now, I hope that the concept of acceleration and velocity is clear to you. When we say that an object is accelerating, so as I was saying, when we say that an object is accelerating uniformly or constantly, that means the object's velocity is increasing by the same amount in every 1 second. That is, in the first 1 second, the velocity increased by how much? 5. It was at 0 and now it became 5. Then in the next 1 second, it increased by another 5. The velocity is changing by the same amount in every 1 second. That is what acceleration means. So if you are to talk about acceleration of an object, you mean that the velocity of the object increases by the same amount after every 1 second. And what happens to the distance if the velocity is increasing? If the velocity is increasing, the distance also increases, but not uniformly. When accelerating, the distance does not increase uniformly. So keep this in mind. When we talked about constant velocity, we meant that the object's distance covered in every 1 second remained the same. It was 2 meters after every 1 second, right? Because it was moving with a constant velocity. But when it's moving with a constant acceleration, that means the velocity is increasing by 5 after every 1 second, but the distance is changing. In the first 1 second, it covered a smaller distance. In the next 1 second, it covered a larger distance. So there is a difference in the change in distance for constant acceleration and constant velocity. We'll discuss more about this later in our next videos. Hope you have a bit of idea and a clear concept of what acceleration is and what velocity is. All right, stay tuned and subscribe to the channel so that you can keep on watching more videos on the topics for your O-level physics and A-level physics. I hope the video helped you out. We'll be coming up with more videos to help you out, clear your concepts in physics. Stay tuned, stay safe, stay well. All right, everyone, take care. For today, that's it.